Okay, so for this time I wanted to implement MD5, which is a message digest algorithm. So it is usually used in hashing file contents into a really small size, for example into 128 bits. And yeah, like before finding out that it's really not secure and stuff, it was also being used in probably storing passwords inside databases and stuff. I mean, it's still better than doing plain text, but it's not that great. So I just wanted to implement the algorithm of hashing and then also have the option to brute force over a list of passwords and try to figure out which one gives you the hash that you provide. So yeah, as I said, this is a hashing function, and the difference between hashing and encryption is that hashing is only a one-way function. So you take a password, you apply the hashing function to it, you get a hash, but you cannot go back from the hash to the initial text. Where the encryption function, you can do that because, for example, in RSA, it has multiple keys, the public one, the private one, and you use both of these keys to go back and forth between the the encrypted version and the non-encrypted version. So yeah, that's basically the difference. So we have a hashing function, which is only a one-way function. So yeah, basically let's see what I want to achieve. So let's say we have this MD5 sum, and it's also the same as the one from Python. So let's use the one from Python. I already had the command done. So yeah, if we use this string in MD5, we get, as I said, this what is it, 128 divided by 8. It's 16 bytes, right? So we have 16 bytes of data. And if we use MD5, you can do the same thing like echo dash n to skip the new lines. Then we put this thing and MD5 sum, and we should get the exact same result, right? So MD5, I mean, obviously, they are both like this is in the standard library of Python. This I think it comes already installed with Linux, so uh, surely they work. And yeah, the idea was to implement the same thing, so already have it. I'll Yeah, I wanted to change the video type a bit, so um, yeah, hopefully I'll do an explanation before this. So yeah, we can let me just rebuild everything just to see that it still works. And yeah, basically we can try to use the tool first. So build main and see we get the same hash. We can even make sure that it's the same by doing something like this should be equal to this thing, and yeah, we get through, so that's pretty nice. And then how about being able to brute force the password? So something that we would need is a dictionary. So let's see if I have an example. I have a really small one. So the dictionary would be, let's say, just a list of words, and we separate them. Usually they're separated by new lines in big dictionaries. The one that I use is from seclist. So seclists GitHub. This is like pretty well known repository of uh, like plain text passwords, paths in the URLs, stuff like that. Like it has a lot of cool stuff for security. And yeah, I mean this is just the test one, a dummy one to show how like a password list looks like, because yeah, opening something like RockQ, it's pretty huge. It has like what, 14 million passwords? Yeah. Anyway, yeah, and the idea is to go through all of those passwords in the list and apply the hashing function on them, and then compare that, basically just compare that with what we give as the input. So here we hashed my password and we got this thing. So what you would have to do is put the hash in and then run build main. You would probably say something like brute force, like the flag to brute force the password, and also provide the dictionary file. So let's say we give it RockQ, and yeah, it actually manages to find that, right? And it gives you which password matched. So that's the idea. As a small idea of how this algorithm works is we split our input data into blocks of, like, I think, if I remember correctly, it was um, 64 bytes or something. So yeah, 64 bytes. And yeah, we pad the message with zeros and stuff. You'll see that more in the implementation. And yeah, at the end, like, the idea is we have a state and we keep doing operations on this state. A, B, C, D are basically our input data, the splitted input data, and we apply all these functions, and these are the functions that are being used. They are just bit operations, but yeah, just doing random operations on this state, and it provides us with a constant size value. And yeah, usually that's something that was being used in like storing passwords in MD5's hash. So they would take the password from the user, apply MD5 to it, and then store that hash into a database, right? So yeah, like, an attack would be to find a collision because it has a lot of collisions. Or if you have the hashes, you can try to use brute force on a really big list of uh, passwords to try to find the password. And yeah, that's mainly the idea of how to, like, how MD5 works. And now there are better algorithms than MD5, so I don't know if they are said in this page, but you know, like SHA and the other ones. So yeah, I guess I'll just scroll a bit down just to make it a seamless transition. And yeah, see you when I do the actual coding. Okay, so basically, to implement the MD5 algorithm, I just, went to Wikipedia and started copy pasting stuff from there. So first, we need these constant values, which are basically like used throughout the algorithm. This S value is like rotations of our data, and then as you see now, the K value is like taken from a sign or something. But I thought it was really funny that Copilot actually realized what I was trying to do, and it was auto-completing everything itself. But I mean, at the end, I just went ahead and copy-paste stuff from Wikipedia and formatted it nicely, because you never know what if it would introduce some really small mistake that's, not really good. And yeah, then I copied this other stuff, and pretty much that's the initial part, just copy pasting the constants that are used throughout the algorithm. And at this point, I saw that we actually need to read some stuff from the input, like this would represent our message that we want to encode. And I thought that, well, I already have that ds.h library, and the idea of ds.h is that we can reuse some stuff from it, like the string builder, or The string slices, that's something else that I used. I don't remember exactly right now what else, but yeah, right now I was trying to figure out how to use the characters, and as you can see, like there's a difference if you use characters or unsigned characters when you read input. So at that point I was like, okay, right, I cannot use string buffers. I have to use actually for the message, like um, for the message itself in the algorithm, I had to use bytes basically, like unsigned characters. So I just made that message array structure, which works with the dynamic array that I have, or at least with the macros for it. So yeah, I just used the da append macro and tried out, playing around with some examples to figure out how to correctly place that data, like the values, because as you saw, like you have to pad the message in MD5. You need to have it like 512 modulo, pretty much. So yeah, and at this point I was like, okay, now we just need to read some input. And I think I did this before, but I just wanted to, re-implement it and give the user the option to either read from a file or from standard input. But yeah, and for the start I just said, okay, let's read into a string builder, but by the end of it I'll change it to just a char pointer, because there's not really a need to read into a string builder. So yeah, then I just did the classical if, if we have a file, like if the file name pointer is not null, then we read from a file, and otherwise we read from standard input. And yeah, then read the file line by line and append everything to the string builder. So that's how I wanted to do. Then of course just the usual memory um, handling, and just checking that everything is closed and freed at the end. And yeah, I think at this point I thought that, well, why not just return just the char pointer there. So there's not really a point to return the string builder itself. So I just created it in the function, and at the end I just did the build. I call the build function on it. So it converts everything to a C string pretty much. Of course, don't forget to like free that, and yeah. Then inside of the main, we can just simply call to that, and here you can see that I piped hello into the main, and yeah, it actually read it. So yeah, the goal would be to manage to have this implementation be the same as the one from the Python standard library, pretty much. Yeah. So that would be the goal, to have the same MD5 hash as in Python. Okay, so yeah. Then I went ahead and created this build message function, which will take the message that we provide, and it will convert it to the format that it's expected by MD5. So we take the length of the string, then we have to append, well, first we initialize the string, but then we have to append a character to that string, and I think that character was a single bit of 1, which translates to x80 basically, because we work with little endian, and that was a problem for me. Like I couldn't figure out if it was little endian or big endian sometimes, but I mean I should have just trusted that it was everything little endian. But I mean, yeah, not that difficult though. So yeah, look, I appended the x80, and then I appended zeros until it was padded. And at the end we just have to add the length, but here I was a bit confused because I didn't really know if it was little or big endian, but it was fine just to add just to add the length as it was, basically not really bother with it. So yeah, as Copilot suggests, basically that's the way to do it. You just iterate from 0 to 7 and put each byte into the end of the array. And yeah, here I was trying to printf the thing just to see how it looks. And yeah, for 80, because we had 10 characters, the length would be 80, like 80 bits basically. And for 1000, yeah, it's 8008 bits, because there's also the 0 at the end or something, I guess. Or it's the new line, because I used print, yeah. I used print from Python, so there's a new line. That's why it's 8008. And at this point I just went ahead and started to implement the MD5 hash algorithm itself. So here I just went to NeoVim and started to implement the function. Here we pass in the message structure that we did before, and that's just the array with the bytes as the MD5 expects them to be. Here I was just deciding if I should just return the digest or the numbers. I decided to return the numbers themselves just to follow the algorithm a bit more in detail. And then I just went ahead and started to basically copy paste from Wikipedia. First we had to initialize these A, B, C, and D variables. So that's the, well, I guess the first thing was to get the for loop over 512-bit chunks, which is basically 64 bytes if you divide by 8. Then we had to split each chunk into 16 32-bit words. First I tried to make a structure, but after I started to type in the code, Copilot actually helped me, and I realized that if I just take a pointer with a type of int into my bytes, it will just cast it to the expected type, right? So we just have to be careful to only index up to 16 into it, because there's no limit, let's say. Then I did those A, B, C, and D stuff, and then I had to go up until 64, right? So for 64 bytes basically. Yeah, as you can see, there was the first mistake basically. But then I had to implement the computations for these F and G. And F is like the hashing done on the current block, and G will be some sort of index into K, or if I remember correctly, into one of those two things. To be honest, I don't remember which one. I don't think it's really important that, like, I mean, the algorithm gives us the hash, but it's not really, oh, it's because there's like math behind it. I guess it is some math behind it, but it's not really that we need to understand how it works. It's just, well, we just follow the rule as the author said it's done, basically. And yeah, at the end we just have to get F, and I think we have to put F into one of those A, B, C, D, and then switch them around. So that's what I did there. Yeah. And then for the digest, we just have to call to this function and then display the A, B, C, and D as characters. And yeah, here I was thinking, well, shouldn't those characters be in little endian? Like, that's what it says in the comment. But yeah, I don't know why I gave up so easily on it, because that's something I should have done, right? So I just printed them as they were displayed, but that's not really the right way to do it. We have to use some special function. I'm curious to see if anyone knows about that function. Like, you apply it on a number and it converts it from, one endianness to the other one. So yeah, here I was comparing the hashes, but they were totally different. Like, there was nothing related between them, so I was like, oh damn, that's bad. But Anyways, so instead of trying to figure out why it didn't work, I just decided, well, let's just refactor the code a bit and create some proper like build for it. So I moved some of the stuff into an include folder and the source code into src. Then I went ahead and I think I wanted to add argparse to our project so we can just easily have command line arguments. And the reason was, well, this way we can add the file name as an argument, and we can do some other stuff as well. So here I just started to work on the md5.h, let's call it the library, but yeah, so I started to put in the like all the functions that I had, but then I quickly realized, well, why would I expose this message array to the user? Like, wouldn't it be easier for the user to just have an MD5 hash function that takes in a character array and it returns back another character array? So it's just much easier to have just one function, MD5 has hash digest, which gives you back the digest of the hash pretty much. So yeah, so here I just copy pasted everything into this file. So yeah, also made that ds.c file that just defines the implementation for our data structures. And here I just had to fix the small error that was introduced because of the different type. So yeah, in the end, we should have a single function that converts a string to its MD5 hash. I don't know why I was highlighting that, but anyway, I guess I was just maybe saying that, well, free the memory and stuff. But yeah, basically instead of having everything in main, we now have multiple C files, and yeah, now I had to implement the makefile. And I did this makefile so many times that I can just go into my project, in like any project I have, and go into one makefile and copy paste it and just adapt it to the current one, which will still be similar because, as you see, I don't delete everything. I still keep those wildcards. I find them really cool to use. Like when I found about them first time, I was like, wow, that's a game changer. Um, yeah, so here I have no idea why this didn't like the defer label because I was totally using return defer there, so I have no idea what was the issue with that. But I think I just ignored those warnings after like some time. But yeah, like at this point we have now like a pretty nice structure for the project. So yeah, and the cool thing is that it still works, although it's not giving us the correct hash back. So we might have to fix that. And the last thing I guess that I did was to also put this read file into a io.h library. Again, just to make the main.c file a bit cleaner. So it, yeah, now it should be more or less basically nothing in the main.c file. So yeah, and right now I just started to work on the argument parser. And the first thing that, like the first argument that I added was, I think, the f. Although I had to remember again how to do it because, again, I forgot how to use the argument options or however I call them. I always forget about their name. It's argparse underscore options, my friend. Yeah, there I got them. So yeah, basically the short name, the long name, description for the argument, whether it's required or not, and also its type. which is value for the file, because it's -f and then the name of the file. And then the other thing would be to brute force, or like to break the given hash, and we would attempt to figure out the password that was used to generate that hash, right? So, but I mean, for debugging purposes, you'll see that I just search for one password, and I mean, you'll see. But yeah, like if we have the brute force flag enabled, which is one of our arguments, we'll do brute force, and otherwise we do hash. So like the idea is, we copy the old contents of main into the hash md5 function, and we just do that thing. And then for brute forcing, we actually need a dictionary file. And I think, I don't remember if I wrote it already or not, but I think yeah. So if not provided, we said that we read from standard input the file. But if we say that we want to brute force, we will actually require the file name, because we have to read both the thing that we want to brute force and the dictionary. So the dictionary will be basically a list of passwords that we think that are possibly there. So yeah, like a list of guesses. Maybe that's more correct to use with the brute force idea, right? So yeah, I guess here I was just using the string slice to be able to read from the dictionary line by line and split it into words. So I just had to add the implementation and also the memory management, obviously. I always like to do that. But yeah, at this point I decided to do, it's basically a for loop or a while loop over the input of the dictionary file, and we split by new lines by using this ds string slice data structure. And yeah, the main idea is to get the current guess. We apply MD5 on it, and then we have to compare the MD5 hash with the hash that we provided. But I mean, for the debug purposes, I just provided, instead of providing the hash, I provided a password, that is like the plain text, applied hash on it, and then compared the hashes. So it's like how you would do it, let's say if you want to send your password to a login API, like how APIs work. You send them your password, they apply the hashing, like whatever they do with the password, and check against the database. So that's how I implement it here, like just uh, compare the hash. And here I created a dictionary, like a few words, like nothing fancy. But here we provide the brute force and dictionary, and yeah, send in the password, and we try to compare it. Here I realized that I needed to actually add the hashing just to debug. So yeah, I just computed the input digest and then compare the digest with the input digest. So if we send the password that's in the database, we get back the fact that we found it. And here I used seglist, which is, I guess, a repo for cybersecurity stuff. And yeah, good password there. And yeah, I was just trying out passwords from that seglist, right? And here I was searching for RockQ. It's one of the like most well-known passwords list. But yeah, I was like, why can't I find it? And it's like rockq.txt, and I think at some point I found it, but it was archived, so I had to unzip it. The Yeah, here I was trying to use find. I don't know if I used it right, but anyway. And yeah, like then I was trying each individual part because it also comes in parts. I don't know if it's the entire file split into parts or if it's like subsections of it. I have no idea. But in the end, I just said, okay, you know what, like just give me the archive, unzip it, and yeah, it was really slow because of the printfs, so I removed the logs. But with it takes like around 6 seconds if you have to go through the entire raw queue. But yeah, and here I said, okay, let's change back to actually providing the hash and trying to break the hash, right? Like searching for that hash in our dictionary. So yeah, like at this point, like the idea of having both hashing and the brute force algorithm was pretty much done. Like um, yeah, I guess we were able to do it, but although it wasn't really right, like we didn't get the right hash in the end, right? Like that's the only issue we have. But you know, I just wanted to create the repo, save the progress for now, and then try to work again on the same problem. Like one of my ideas would be to use pthreads to improve it, or like try maybe to implement some sort of single producer multi-consumer maybe, although I don't know if that's like a good approach. But in the end, like after I here I was just writing the readme for the current implementation. But yeah, like just simply explaining how to use the CLI tool. I mean, it's just the MD5 hash clone, and I just pointed to where to find it on Wikipedia. Although I have like I always forget how to use links in Markdown. Uh, you have to put square brackets on the word and then normal braces on the link. But at this point I said, okay, let's actually try to do the pthreads version, because why not? Let's just try to see if stuff gets sped up a bit. And spoiler alert, it got, but I mean, yeah, you'll see. So first we have to buffer every word into an array, just so we can split it into chunks. So like we'll have all the words from the dictionary inside of this list, and we'll give each thread one part of the list. So the first thread will get the first quarter, the second quarter, and so on. So that would be the idea. I think here I was just trying to mess around with the freeze and stuff, because I don't know, I just forgot about some freeze probably, and I was using Valgrind to find those issues. But yeah, after a bit of struggle, I actually managed to get that array that I was talking about, and I started to work on pthreads. So yeah, the idea is let's take out the code that we have in the MD5 brute force function and move it into the brute force thread function. So the only difference, as I said, is that instead of using the index from 0 to end, we'll use it in a certain range from start to end. So here I change that, and we also have to use the arguments. So yeah, that's the only thing I don't like about pthreads, is that you have to use void pointer args. Although I mean, makes sense. But yeah, basically we and yeah, another cool thing about this implementation is that when you find a match, you have to use a mutex to check it, because if another thread tries to access the same memory location, you can run into race conditions, right? So we want only one thread to be able to access the memory that's common between all of them. But as you can see, like when we access the words from the array, we don't need a mutex because it's different indices, so it doesn't overlap. And it's also just reading, it's not writing. So that's also something. If you have like read-only stuff, it's not really important to use mutex for them, I think. I mean, to me, it makes sense if it's read-only. So here I was like, what if I put a pthread there? I cannot use goto. That's so weird. So I moved them up. I think it was because of the initializer of the mutex though. So yeah, I initialized everything, all the arguments and stuff. Make sure to put the end to be the array count, the end of the for loops, and then we have to join the threads. And at the end, if we actually found a match, then that's good. Otherwise, it means that we haven't found any matches. So yeah, basically we searched for that match, and it's just the code from before, but it's split into chunks, like each thread solves one part. And yeah, when I said like the spoiler is that it is faster when it has to go through the entire list of words, but if you like, it takes like 1 second, I think it was like 2 seconds when it doesn't find a word, right? Like that's when it's faster. But when it actually finds a word, it has to wait for all the other threads to finish. So it's still not like when you actually find the word, it's not faster. I have to figure out how I can do that. Like, would be nice to be able to send somehow a message between the threads. Like if you found the match, then you stop the threads. But yeah, not sure how to do it. Because as I said, if you write to a memory location that's common, then you cannot really read from it without a mutex. Doesn't make sense to me to do that. Although maybe that's the trick. Maybe just on each iteration you check if match is not null, and if it's not null, then you can exit. So yeah, I mean that was the idea. It is faster in some way, the pthreads version, but it's not like it's faster in some conditions, right? If you meet those conditions, then it's faster, and the condition is you don't find any match. Like at least that's when it's faster. So yeah, here I guess I compare them and it's much quicker, but yeah, it's actually not faster when it finds the word. Although it should be faster if the word is towards the end, right? Like it depends. But as I said, probably a good thing would be to be able to check somehow that match, if it exists or not. But I guess yeah, that was everything for the pthreads version. So now I'll just show the issues that I when I managed to fix them and actually get them. So I created the repo, and yeah, pretty much that was everything for today. So yeah, here I just had to modify that 63 into 64, so that was the fix. And there was another one, like putting parentheses around the or operator, because apparently that makes things different. So here I realized that, see, like it looks pretty similar to the actual hash from Wikipedia, but the order of the bytes is not correct. So then I was like, okay, how can I use printf? I was still lazy to write the for loop and show the bytes in the right order. So I was like, can you do it with printf? Or I mean sprintf, what I was using. But then I thought, well, no, I used before a function in like networking. It was something like host to something, right? Like that's the name of the function, host to endian, big endian or something. So I said, okay, what if I use host to big endian? And it was actually like what I actually need to use, right? So that H to BE or BE to H, it's what's converting the numbers to have different endianness. So I was pretty excited that I actually fixed it. So now we get the right hashes. So yeah, now we can actually use our so yeah, like now we can actually use our CLI tool to try to break hashes generated from Python, for example. So that's really cool. And yeah, I mean now it actually works as we expected it to work. So that's pretty nice. So yeah, I just wanted to try out a new video format basically. So the idea is instead of just doing the usual stuff where I put the raw coding session, I thought that, well, I mean, that's basically the same as just streaming it, but without the streaming part. And yeah, I thought why not just, if a project takes me multiple days or even one day, I can try to speed up the video a bit, like the implementation part, and just explain my thought process more or less in that section of the video, more like, know, coding what happened in the last week or something, or like in the last few days. And yeah, basically this for this one, yeah, it was only one day, but I wanted to try out, see how it goes. And yeah, I have like the usual intro where probably I'll show the results first. I don't know if maybe that's not the best idea to show the spoilers. Maybe keep them at the end or show a bit of the results first just to make it more intriguing and worth watching the implementation. Just to give you like an idea of what the results will be. You know, like reading the abstract of a research paper or something like that. And yeah, then doing the coding and maybe at the end showing the full results. But like if the results are really small, like in this case for the one that I will do now, like the results are pretty small. You don't have something huge. So I mean, I probably keep them just in the intro. So yeah, I mean, yeah, that's the idea for this video. So see you there.